Good afternoon, everyone. My name is Mr. Adeleke David. I'm a I'm a tutor at Mother's Choice Tutorial Center. I just want to use this opportunity to actually teach us and actually look into some topics in mathematics, because we want to maximize this holiday. We don't just want to relax at home, just doing nothing, but we just want to actually learn and teach ourselves, impact lives in this course of this holiday, to actually brush ourselves up and not to keep our brain in a static form. All right. So we're going to be looking at the subject matter mathematics and the topic, which is theory of logarithms. And now, in the place of theory of logarithm, I don't want to rush it. I want to take it slowly. Theory of logarithm, we understand that we have the usual logarithm whereby we have the numbers and logs, wherein at the end of the day, if it is addition or subtraction, and or we have it as in the place of multiplication, then we look for the antilog, that's the antilogarithm. So, but in this state, what we want to look at is theory of logarithm. Now, looking at theory of logarithm, this is what theory of logarithm is actually all about. Note, theory of logarithm shows the relationship between indices and logarithm. That is one. Then the second one, the theory of logarithm actually helps us to define the laws of logarithm itself and for us to be able to solve questions under it. Now, let's take the following as an example. But before I proceed, let me quickly tell us this. We have indices. In the place of indices, we have about 7 laws, which starts from the additional law to subtraction law. From subtraction law, we move to power law. From power law, we move to zero law. That's any number raised to the power of 0 equals 1. Then from zero law, we actually move into negative inverse law. Then from negative inverse law, we move into fractional index law. Then from that, we move into negative fractional index law, where we have it in a fractional form. Then we have the negative inverse there. So, and the likes. Now, we now move into theory of logarithm. Those laws that we have in the place of logarithm. Don't forget that we also have power law there. No. So when we are now merging it up with theory of logarithm, this is what it gives us. The first one we have is also a law that actually talks about the additional law or the multiplication law. You understand that when we have multiplication, it instead in the place of indices, it also signifies that we have it as addition. All right, let's proceed to this. Now the first one is that deals with the additional and the multiplication. So when we have something of this nature, log, we say we have log A base B, then that's multiplied by B, something of that nature. So it means that we have it as log A base B plus log B base B. Do we get that? Alright, we'll proceed to the next one. Looking at this number 1, there is something I want us to actually note here, because I'm going to come back to it. Note this. Now, we'll go to the next one, which actually talks about the division, which means that we have it as subtraction. So we have log A over B base B will give us log A base B minus log B base B. Do we get that? Alright, we'll proceed to the third one, which is this. We have it in form of the power law. In indices, when we have something of this nature, we have something like this. A raised to the power m, close the bracket, raised to the power n. It means we have it as a raised to the power m times n, which tells us that we have a raised to the power m n. That is, what I'm talking about is when we have 3 raised to the power 2, close bracket, raised to the power 3. It means that we are having it as 3 raised to the power 2 times 3, which gives us 3 raised to the power 6. That is what this implies. Now, we actually want to do something here now, presently. So we have something which is a law such as this. We have Now, this is what we actually call the power law. Now, having this as the power law, we look at it critically, telling us that this means that we are going to be having it as x log A base B. Now, the knowledge of these laws actually helps us to be able to solve questions. Now, solving questions in what stead? In the place of when we have something of this nature and we see a question that is actually pointing at this, we know that, okay, this is the way I'm going to actually solve it and I'm going to be able to get my answer. Do you understand what we're saying? Alright, so we proceed. Now, having this, we also have another one, which is the change of base. That's when we have something like this, log A base B, which is going to give us something of this nature. At the end of the day, we'll be having log A over log B. Now, note this, that what I'm actually saying is actually simple. For this number 1, I'll give an example. For number 2, I'm going to give an example. For number 3, and for number 4, and the rest of them that I'm going to be outlining. Now, note this. What I'm actually saying here is that if I'm having this as log A base B, now note, in logarithmic table, we don't have anything that is actually in order base. Every of the log in the place of logarithm, what we have it is in the base of 10. That is the reason why you see that when you want to calculate your anti-log in from your calculator, when you press shift plus log, this is what it brings out. It brings out this. Then you raise to the power of whatsoever you want to actually write. That is what it does. If it is 1.732, then it's going to give you your answer. You understand what we're talking about? So that is the place of anti-log. So in the place of log, it's also in the place of base 10. Do you understand what we're saying? So we proceed here. So from here, we proceed to the next one. When we have a number or a log which is also having its own base, it's equivalent to 1. Now, note, I said I'm actually going to come back to this number 1 here. Now, note, if this was supposed to be a number, take this example. Now, assuming I'm having something of this nature, that I'm having log 35 base 10. Oh, let me say log 5 base 10. Now, I actually know that this log 5, for me to actually have this, I know that this is actually it's actually as a result of me having the combination of two numbers, which is log 7 times 5. 7 times 5 gives us 35. So having that two combo, it means that what I'm having is log 7 is 5, then plus log 5 base 5. So if I'm to actually work on this now, what I'm going to be having is log 7 base 5 plus, because this is log 5 base 5, this is what I want to actually prove out here. So when I have it as log 5 base 5, owing back to this law, which actually shows me that log B base B equals what? 1. So I'm going to actually have what here? 1. Before proceeding to solve the next question there. Hope we are getting something here. Now, I will actually have to go to the other part of the laws so that I'll be able to run through all the questions at the same time. I just use that to cite an example of what I'm actually talking about in this stead here. So, from here, we still have some other laws, but let's just pen it down here and we'll proceed from there later. So, let's have some worked out examples. And now note that we can actually have some questions that looks like quadratic equation, but it looks as though it's an equation. But on the other hand, it's actually a logarithmic question. And we have something which is called the logarithmic form and the index form. That's why we convert numbers from index form to logarithmic form. Take for example, I'm having something of this nature. Alright, this is what I'm trying to say. So when we have it from index form to logarithmic form, this is what we're actually doing. We're saying that when I'm having something of this nature, a equals x raised to the power b, this is actually in index form. So I'm going to take it from this index form to logarithmic form. So if I'm to take it from index form to logarithmic form, I'm going to be having log a base x equals b. This shows me that I've actually taken it from index form to logarithmic form. Now, if I'm having a question that goes in this form, in this format that I'm actually having like this, let's take for example, say I'm having 8 equals 2 raised to the power 3. Are you getting that now? So this is in index form. So I'm going to take it from index form to logarithmic form, where I'm having log 8 base 2 equals 3. Do we get that? So it's as simple as that. So taking numbers from index form to logarithmic form actually gives us an insight to also be able to solve some certain questions. Are you getting that? We actually stop here. Now we're taking numbers from index form to logarithmic form. So when we have this, it actually gives us insights to actually solve questions. So if you're having questions in this form, you should be able to actually convert it from index form to logarithmic form. So having that understanding, we can now proceed to solving questions on the theory of logarithm. Let's start with this. And now note, I quickly want to say this, that you don't need to cram all those laws. What you need to do is to know the laws. Knowing is different from cramming. When you know, you'll be able to apply the laws in your solvent, which is going to actually make the work very much more easier for you to be able to actually attend to, and you'll be able to get your answers correctly. You know, most students find mathematics as a difficult subject, which is not. It is just your ability to devote your time to practice, and you work out things on a daily basis. It's going to give you an advantage and an edge in understanding the techniques and the applications of mathematics. Alright, so we take some questions. Question 1. Sorry about that. Alright. We have this question. Evaluate the following. A. Log 4 base 10 plus log 15 base 10 minus log 3 base 10. The B. Log 64 base 2 minus log 6 base 2 plus log 4 base 2. Given that log 2 base 10 equals 0.3010 and log 3 base 10 equals 0.4771. Alright, now let's actually solve this question. We have this as a number one aspect. So we have these examples. So we want to take the solutions to it. Now we have log 4 base 10 and plus log 15 base 10 minus log 3 base 10. Now what I do is I have every of my logs in the same base. So that is the first point of contact. And I know that this plus here shows something. It shows me that I'm having it as multiplication, and this minus here shows me something too, that I'm having it as a means of division. Then what I'm going to do is to actually take it from this form to its initial, which is this log base 10 open bracket 4 times 15 over 3, which is actually, we have it as 3 here 1, 3 here 5. So I'm having log 4 times 5 base 10. It gives me log 20 base 10. Now note, to some students, what they will just do is they will say that it becomes that log 20 base 10 becomes log 10, log 10, we have it as log 10 raised to the power 2 instead. It is wrong. Now let me quickly tell us this as well. Now when we have something like this too, it is quite simple. Note that log 5, if we're being given log 5 too, log 5 2 is also meant to be log 5 base 10 is actually 0.6990. So we can have that added to it. Now having this, it is actually wrong. Now what you can just do for us to be able to actually get our answers properly is you look at the combo as the combination of what we have on the board. What's the combination? The combination of what we have there is log 4 multiplied by log 5. Now let's quickly break that down and make the work very easy for us. So what we just do is we just take it like this. We say that we have it as log 4 base 10 plus log 5 base 10. Now what is this? We can actually break this down. We're having this as log 4. We can break this down to 2. So we have it as log 2 raised to the power 2, because we understand that in the place of indices we have 2 raised to the power 2 or 2 raised to the power 1 equals 2. 2 raised to the power 2 equals 2 multiplied by 2, it gives us 4. So having that understanding, we have this here base 10 plus log 5 base 10, which gives us power law sets in now. So for this, note this, that this is my left hand side. That's, I'm going to represent it with LHS. I'm going to make us show us what I'm actually talking about. Log 2 raised to the power 2 base 10, power law sets in. So what we're going to be having is going to be 2 log 2 base 10, in which we actually talked about in law, under law 3. So make it known, that is law 3. So we proceed from there to having it as log plus log 5 base 10. So 2 open bracket. What is log 2 base 10? 0.3010. Then plus, what is log 5 base 10? 0.6990. So when we accurately multiply, we are going to be having this as 0.6020 plus 0.6990. So at the end of the day, what we're going to be having is, we're going to be having 0, 1, take up 1 as well. So that is 10. You write 0, take up 1, you're left with 12 plus 1, that's 13. So you're having 3. You take, since you're having it as 6 plus 6, that's 12. You write plus 1, that's 13. You write 3, raise the 1. So you're having just 1.3010. And that gives us our final answer. Do we quite understand that? Alright. For you to actually get what I'm actually saying, I say 0.6990, you have 0.6020. This is 0, this is 1. Take off 1, you write 0. Take off 1, you write 3.1. So you bring it down 1. So that is what actually brought us to having this. So, having this understanding, we're going to proceed to the second question. I'm going to actually take another question. After this question, I'll take another question. Then I will actually end this theory of logarithm series 1 today. So after the next question. So we take the next question, question B. We have it as log 64 base 2 minus log 6 base 2 plus log 4 base 2. So what we do is we interpret this question having it as log 64 base 2 plus log 4 base 2 minus log 6 base 2. So it gives us something. Something is actually common. The same format we use there. We have log base 10 close bracket 64 times 4 over 6. Take it to 2, sorry about that. So we have this. So this, we have 2 here. That's 3. 2 here. That is 2. Okay, good. What do we do? What we just do is, when we multiply this together, it gives us 128. So we're going to be having log 128 base 2 and minus log 3 base 2. Do you understand that? So from there, we actually proceed solving it the proper way and get our final answer. We'll break it down. We'll be having log 128. When we continue with this, 2 raised to the power 3 gives us 8. 2 raised to the power 4 gives us 16. 2 raised to the power 5 gives us 32. 2 raised to the power 6 gives us 64. And 2 raised to the power 7 gives us 128. So what we just do is we break that down, which is telling us that we have it as 2 raised to the power 7 base 2. Do we get that now? So from there, we have minus log 3 base 2. Log 3 base 2. So we're having 7 log 2 base 2 minus log 3 base 2. Now note this, that when we have something of this nature, what we actually referring to here is actually what we have in the place of the second law of logarithm. So, and it gives us insight to what we have there. Alright, so what we just do is we actually work this out, because you already understand that log 2 base 2 gives us 1. So we have it as 7 times 1. So we know that that is 1. Then that's 7. Then minus log 3 base 2. So here we are having 7 minus. Now let's look at log 3 base 2. Now note. Note this. The log 3 base 2. What do we have it as? We don't know the value. Why? Because we understand that logarithm does not deal with base 2. It deals majorly with base 10. Because we said it earlier on when we wanted to start this class that logarithm actually works with base 10. So what we just do here is we impute what is called the change of base. Imputing what is called the change of base, that is the law. What's it called? The law 4. So we impute change of base wherein we are having this. So we are going to assume that this equals x. So it is an unknown. So what we're going to do is we're going to say that log 3 equals 2 raised to power x. So what we do is we take it from this logarithmic form that it is, we take it to index form. Logarithmic form. And we take it to index from 3 equals 2 raised to power x. That is actually index form. Now, having this knowledge, now we take it further. To what aspect? We take log of both sides. So when we take log of both sides, we'll be having log 3 equals log 2 raised to power x. Power law sets in here. We're having it as log 3 equals x log 2. You understand that? Power law. That's law 3. According to law 3, we'll go back to it. So we'll proceed from there. That's so from there now we want to actually look for the value, that's x. So therefore we divide both sides by the coefficient of x. We're going to be having this over log 2 over log 2. So we are having x to be log 3 over log 2. It gives us, what's log? This shows us that we're having it as log 3 base 10, log 2 base 10. Do we get that now? So we are having it as 0.4771 over 0.3010. Alright now. So now, our final answer is this, 1.5851. So now, having known that this is the value of log 3 base 2, we therefore impute this value into this, 1.5851. Hence, we subtract. We have this to be what? 7 minus this, it gives us 5.4. So when we have it as 5.4 as our final answer, so we can actually say that we have our final answer to be this. So we can just say is 5. Because when we actually start, we have it at 7.0000. We have 1.5851. Because we need to make mathematics much more simpler for every one of us to be able to understand. This is 9, 9, 9, put 1 there. So this is 9, this is 4, this is 1, and this is 4.5. So you have a full answer here, wherein we can actually approximate and say that we have it as 5.42 as our final answer. Alright, so we understand this now. So we're going to actually stop here for today. Once again, don't forget about Einstein said something. He said, it's not because I'm smart, but it's because I stay much more longer with questions, with problems. So take out your time to actually study and look into it properly, and you see that mathematics is quite simple. Note every of the laws that we have actually stated, and now we have actually applied every of the laws in the questions that we have actually touched. Meet us same time tomorrow, and we'll proceed from there. From Mother's Choice Tutorial Center, reporting live. Mr. David Adundeke. All right, see you next time tomorrow.